Hi, welcome back.
Hello.
Hello.
Good morning.
Good morning. So we're starting Unit 2 today. So this is day 1 of Unit 2 stuff. We're talking about inverse linear functions. The past few days, we've been working with just straight up linear functions. We've been graphing them. We've been doing with the inequalities of them. All that good stuff. We've talked all their characteristics. Now we're going to talk about the inverse. Now what an inverse is, like, it's the inside out, kind of the go in reverse of a function. So if I've got some function here, we'll name it f, and it takes these numbers and it does stuff and it turns them into these numbers. The inverse, which will be this one over here, inverse, and I'm going to denote it with a -1 next to the little letter f, or I'm going to denote it with a little mark by the little f. That's what that means. So this is pronounced f inverse. It's going to take what was here as its input. So in my original function, the thing that we got out of the function is now the thing that we're going to put into the inverse function, the undo function. And then the thing that we were originally putting as the input of our original function is what comes out of the inverse function. Okay? This is like your Control Z on your computer, the undo. Oops, I made a mistake. Let me back it up once. Okay? All right, let's practice doing that. We're going to go to here. You're going to see me working in 2 different colors today. I'm doing blue and orange because those are some really high contrast colors. All right, so this one, straight, just standard, like normal every day, I need to find what f of x is. So I'm going to take my function rule up here. I'm going to substitute in my value for x, and I'm going to crunch the number. Okay, no big deal. Do, 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 do. That's supposed to be a 4. All right, that feels really easy and comfortable, yes? Okay. Now, we're going to take what was here, and we're going to put it right there for the inverse. Don't think hard about it. There's nothing special. Just grab those numbers and write them over here. Blap, 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 blap. And then we're going to take the numbers that were here, and without thinking hard, we're going to put them right here. And that's it. We have created the inverse. Ta-da! Let's graph them. Okay. Gonna graph this one in blue so it matches. And I'm going to take my handy dandy straight edge maker and I'm going to turn it into a line. I'm graphing the blue one, the original function. And my directions say to label them. So I did them in color, and so that should be obvious, but I'm going to go ahead and go that extra step and label them also, just to make sure that it's clear. So there's my f of x, and now I'm going to label my inverse, my f inverse of x. Graph that and label it. 1, 2, 0, 1, 2, 2. And I'm going to label that one. Yeah, they look parallel. It really just looks like I grabbed the blue one and I shoved it up a little bit and it turned orange, right? All right, so I suspect, at a guess, if I didn't know any better, that anytime I take the inverse of something, it's just going to shove it upwards some amount that may or may not be related to anything.
Don't you mean down? Because It's the purple one, the original one.
Don't I mean down because this one is the original one?
No, the
This one is not the original, this one's my inverse. This is my original. Okay, I'll go ahead and label for you here. It's okay. It's okay, this section is, there's a lot of things that are really easy to confuse because
it's because I switched up
the colors. Oh, okay, no problem. Better?
Wait, so the orange is the same one with
With the little, it's called the inverse. All right, let's go ahead and do this bottom one, and I'm going to keep it zoomed out a little bit so that you can still see the original. And at a guess, I suspect that the line got shoved up, but I'm going to do the second one without worrying about what I suspect should happen, and then I'll see what actually happens, and we'll go from there. Okay, all I'm doing here is that substitution again. And I'll do my arithmetic here in a moment. Right now, just substituting in all the things. Okay, I'm going to go ahead and zoom in here so you can see my substitutions. All right, and this is the point where you guys need to double check my arithmetic to make sure that I did it right, because me and the numbers. Okay. I'll wait here until I get confirmation that my numbers are okay. So don't write them until you're sure that I did okay on the numbers. Yeah? Okay, I've got a couple nods. Yep, okay. Hi girls, sorry to interrupt. Can we have the conversation later? Appreciate that, thank you so much. Alright, so I've gotten confirmation that those numbers are accurate, so I'm going to go ahead and move on. Remember, all the stuff that is here is going to go here, and all the stuff that's here is going to go there. And I'm not going to think too much harder about it than that. That's supposed to be a 2. It looked like a Z, sorry. Alright, now that I have them, I'm going to go ahead and graph them and see what happens. -2, +5, -1, +3, 0, 1, 2, -3, -5, and time for my straight line maker. Creakiest desk ever, right here. And again, gonna label my line. And I'm going to repeat for the for the other line. 5, 2, oops. 5, -2, 3, -1, 0, 1. This didn't do what I expected at all. Yeah, it didn't get shoved up at all. It like spun or something. It did not behave the way I wanted it to behave.
Wait. Oh.
It's okay. I paused. I waited. It didn't behave the way I was expecting it to behave. Okay, so it's not a slidey thing. And clearly, if it were a spinny thingy, like from here, this would have looked like it was spinning too. So it's not a slidey thing, and it's not a spinny thing. If we think back to algebra, it's both. It's a slide and a spin.
No, it's just a spin.
Well, it can't be a spin because this one didn't spin. This one looks like it was a slide. Here's the thing is we did the exact same process between the both of them. All we did was flip the x and the y's position. So it was one thing, so whatever it is that we're doing, it really should be one thing and it should never depend. It should always be the same thing. Because I didn't, well, it depended. I'm gonna flip this one, but you know, there was no exceptions. So what was our 3 transformations or 3 changes in geometry? We had the slidey thing, we had the splitty thing, and we had the reflection, we had the flippy thing. So maybe this thing's a reflection. All right, so let's come back up to here and let's take a guess. Where do we think would be our line of reflection if we were taking the blue and trying to reflect it and get the orange? At the 1, at the 0, at the 0, 0. So going somewhere from the 0, 0 through the 1, 1?
Oh, no, nothing. Well, yeah.
Okay, so from basically from this corner to this corner.
Yes.
All right, so I'm going to zoom way out, and what I'd like you guys to do as well, do this with me, is I'd like you to very carefully fold your paper from that corner to that corner, okay? So we're folding in our line of reflection. And I'm trying to do this just as carefully as I can. I want to make sure that I get corner to corner,
Bam.
which is why I'm doing it so I can see the graph, so I can see the corner, otherwise it'd be blind. And Lord knows where I'd fold it.
Bam.
Okay, we've got it folded.
Oh, wait. Yeah. Yes.
All right, now to test it, what we're going to do is we're going to end up folding it the other way, so I'm just going to give it a light crease in this direction. I'm going to grab a pencil, okay, because I've been doing this all in color. So if you've been writing with pencil, awesome. If you've been writing in color things, grab a pencil. Forage for one nearby. There's some in the pizzeria for you. And I'm going to take my original graph, my f of x, the blue one, and I'm going to trace over it with my pencil a whole bunch of times so that it leaves a lot of my pencil's graphite, the point of my pencil, it leaves it on the paper. So I'm just going to put a lot of pencil lead down. Okay? See how that's shiny? Yeah, do you see it? A little shiny? There it is. See it shiny? I've put a lot of pencil lead there. Now I'm going to fold it on that line of reflection so that that pencil lead is on the inside of my folds. And I'm going to take my pen and I'm going to scrape over the backside, which should transfer all of the pencil lead I left here, some of it, onto this other side so I can see where it ends up. Okay? Was this how you were shown how to do reflections in geometry? Okay. If you...
We had a little reflector thingy that we
You had a little reflector thingy. Yeah, it was kind of maroon,
That
red.
thing sucked.
Yeah, I agree completely. I hated those things.
I did not know how to use those.
Yeah.
How am I supposed to do
All you
it?
gotta do, like, you put it down and like,
I
you
know,
select
but
the
it was like
reflection.
so hard to use.
And then you traced it. And I always got confused with it too. It's like me trying to watch a movie in 3D. It just doesn't happen for me. So because it didn't happen for me, I showed my students how to do this as well. So this was another technique that we had. So if you had me, and I think a few of you did, you might have remembered this portion. If this was brand new to you, hey, hopefully this makes reflections easier. All right, so now I'm going to zoom in. All right, I did it perfect this time. Good job, me. Pat on the back. My lead transferred almost perfectly onto my orange line. It's a reflection. It's a reflection over the line. I think the proper terminology is in. It's a reflection in the line that I folded, which is this line right here, which I don't have an equation for right now, so I can't talk about the name of that line, but it's that one. Yeah, we're going to write it in a second. Let's confirm this reflection line on the other graph. So fold it in the same place from corner to corner. Color over the blue, or your f of x, your original function. Then close up your fold and scrape really hard on the other side with your pen to transfer it. Yeah, we're going to do it to this other graph. And we're going to see if we get it to land on the orange. Okay? All right, so I'm going to zoom way out so you can see what I'm doing.
We have to.
I'd like you to confirm it, because if it's the same process, which it should be, because all we did was flip the x and the y, we should end up with the same line of reflection. So we're going to assume this is the same line of reflection, and we're going to do that reflection here.
We go corner to corner.
Yeah, corner to corner. In the exact same place that we folded this graph, we're going to fold this graph. And if this is true, if this works, then we can we can generalize it. Hi, welcome to proofs. You remember that from geometry? I said if, and I assume this thing, then this is always true. We're checking it, okay? So I'm saying that if this works out, then it should work out for all of my inverses. The folding of this is like, it's not happening for me
That's
to
too
do.
bold,
It's not happening for me to do. Oh my
yeah.
God.
It's right.
There we go.
Does it matter what corner?
Yes, the corner, top right corner to bottom left corner. Thank you. All right, so there's my crease, which I'm gonna make it go the other way now, just so that makes that life easier. Okay, I'm gonna take my straight edge and I'm working with my original function, which is my blue. Color it over like a whole lot. Fold my thing again, and now look, when I fold it, I'm gonna have blue on this side that I'm gonna need to color, and I'm gonna have blue on this side that I'm gonna have to color on the back of it, okay? So I'm gonna have to flip my paper and color this in two sections. Okay, so here's my original line. And then here's my other original line. And so if I look at the back side, there's the full line. And then when I flip it over, it's pretty much, this one I had some trouble folding, so I don't think my reflection line was as accurate as the first time I did it. But you know what? It's close enough that I feel comfortable going, you know, anytime we do this inverse thing with functions, it's always going to reflect across this line, whatever it is. Because I've got two graphs that are completely different.
So we can officially say that it's a reflection.
I can say that inverses is a reflection. Now let's figure out what line it reflects across. So I'm going to look at the green line. And let's get the equation for the green line. First off, what's the y-intercept of the green line? 0, 0. All right, and then what's the slope of that green line? 1 over 1 or just 1. Okay? Either way, you did it right. All right, we're going to use our slope-intercept form, which looks like this. And I'm going to substitute. In place of the m, I'm going to put a 1. In place of the b, I'm going to put a 0. And I'm going to clean it up. Do I need to write the 1? Do I need to write the 0? So this is the equation of the line that inverses reflect in.
And that's the answer for
Y
the
equals
mirror
X.
equation.
The very bottom of the page, it says mirror equation. A function and its inverse reflect each other at y equals X. At that line. Because that's our line of reflection. That is it. That is all I had for you today.